Good. This is a presentation to talk about magnons, which are at the heart of every photon. Maxwell wrote a paper in 1861 on molecular vortices, drawing attention to the fact that if the stress forces in the two directions x and y were equal, but at right angles, then the resultant would be in the z direction. Similar, but importantly, to form 3D electromagnetic energy, there is also a magnoflux spin effect that results in the spinning of the current flux field area if a voltage is applied at right angles to that field. To demonstrate this spin effect, an experiment using salt electrolysis is being prepared to show how a magnoflux field can rotate magnons in the XY direction when a voltage in the Z direction is applied. The diagram shows that, and we will have a look at a quick video to see how it works.
This is a presentation by Magnoflux to show that a spinning field, that magnetism will spin a field. This is a straightforward salt cell that we have here. We put a teaspoonful of salt in the back and stirred it up. Here's a little carbon anode that we've got onto the supply from this 12-volt power supply here. On the cathode end of it, we have a magnet, a molybdenum magnet, which just grab the top of the anode, which you can see changes around, of course, the field on here. In fact, the top is north and the bottom is south. So, and of course it flicks the compass around. If we now switch the power on and we put it in line, so in other words this is now in line with the anode, as you would expect, we get a lot of fizzing and the water, the bubbles virtually come straight up. But because it's a magnet, if I now lay it down at right angles to the solution, we then notice very quickly that there's a huge spin clockwise. So we're now spinning the solution clockwise just because the magnet's there. So no longer do the bubbles come straight up, they spin. If I take it out, turn the magnet over, look, put it in the other way up, then you can see that the spin now has gone anti-clock. So we've now got an anti-clock spin on the magnet. Now this is a very important point because it's something that mathematics in physics has not yet caught up with, and it has an effect, I believe, on the way that galaxies hold their stars together. This the magnetism is what is spinning them and keeping them in place. So that is the experiment I wanted to show you.
This experiment that you've just seen was quite difficult to set up because the problem that you get is that the salt cell, if you just put in a copper rod as the anode, immediately starts to go hazy and you can't see inside. So you have to use a piece of carbon. Use a carbon rod to complete it. So the next slide says that between celestial objects, there's a vast volume of space, x, y, z again, of empty space, but yet it is able to transmit any and all frequencies of magnetic light energy. In order to allow a magnetic photon or Magnon transmission, all space needs to be magnetized. The nickname for magnetized space is ether, and electronic engineers are well aware that radio waves here on planet Earth need to vibrate through the ether, which is possible because the Earth has a magnetic field. The Norfolk Island effect showed that sunspots cause radio interference here on Earth, which means that the sun and the Earth are linked magnetically together, as shown on this little drawing that you're seeing beside the text, with the sun in the middle and the planets running round in circles. As radio waves move at the speed of light, they are magnetically the same as the photons at the heart, and at the heart of every photon is a magnon. During World War II, radio operators at Mount Bates Station on Norfolk Islands noticed strange bursts of radio noise at sunset and sunrise. The phenomena was connected with radiation from the sun at an effect known as sunspots.
This is a magnoflux experiment to show the magnetic momentum energy of spin. Now, here we have an ordinary magnet which has got a north pole at the top and a south at the bottom, as you can see when we pass it over this magnet compass here. It does that. We've got another one, much larger magnet here that really upsets the compass. Now, when I put this onto this television screen, it's a CRT, as you would expect, you see the deflection of the letters underneath. But look, the magnetic field isn't symmetrical. It's got a spin to it. And if I turn this round, of course, it doesn't actually affect it at all, because that spin is being induced by the voltage that's coming up at right angles through the middle of this magnet. Now, this has profound effect when you look at it on the micro scale, because inside atoms and molecules we know that we've got charged particles, which means there's a voltage inside, and we know it's got a magnetic momentum, and now we can see that that magnetic momentum is telling it to spin. If this was on a perfectly frictionless surface, it would spin. If we turn it up the other way, then the spin is rotating in the opposite direction. And this is very significant when we understand atoms, that they are made up of electrical parts, and the electrical side of it is very important to their well-being. If I now take this other magnet, look, of course, it, with the north on top, it's sort of pushing it away all the time. If I now drop it right into the middle, it tries to flip over, of course, but if I drop it right in, then it goes inside with no problems at all and just floats, because it's they're repelling each other. It just sits in there. Now, this is very significant on the macro scale, because if this major magnetic field here in an electrified space were, say, a galaxy, and this inside was a star, then when I move this around, you can see that the star spins. So I can, if I then had lots and lots of these tiny magnets inside, they would all spin just like that, but they'd be all spinning together. Now, of course, they would reject each other because they all repel each other, and that's the way that galaxies are. So what we have is a magnetized universe, and that is very, very significant and needs to be looked into by the world of physics and cosmology.
So you could see from that experiment, which was done with, of course, an old CRT television, you wouldn't be able to do it with a laptop or anything like that. But you could see that because the electrons and the photons are coming through the anode grid, that they come straight out, and the magnetic field then is distorted, but it spins. And the important thing is the spin. So we were talking there about the solar system, and if you magnetize it, which we obviously now know is right, but what happens if you also polarize it? In other words, why would the solar wind, which is made out of positive ions or protons, be attracted towards the Earth? And I think the answer to that one is that the planets are all made of material that has electron shells around the outside. So of course, when you look at them, you only see from the outside an electron, so they are minuses. But if the sun or the stars were all positives, then of course there's a very good reason why any particle or protons on the sun would be attracted to a negative planet which is spinning round it. The picture, which has been redrawn for us very kindly, shows the rays of light, which is exactly in the position, of course, of where the solar wind runs. And we mark the solar wind and the light in red with arrows on, showing the light and the solar wind going to each of the planets. You can also see that our sun is in fact also shining light to other stars' planets, because it can see their negatives and it wants to send them some light. So the stars all push each other apart because they're all positives, and they all have their own planets running around them, but each of the other stars can see it, so we can see starlight. So the current and flux field XY is a spinning area of magnoflux, quantum magnoflux, commonly known as ether. This weighs nothing and is extremely flexible, with its normal position at right angle to our sun's axis, so that sunlight can travel in a direct line to the planet through a sort of magnoflux tunnel of rotating area of quantum magnoflux, magnetic current. So how does this affect power transformers? Electric engineers know that electricity moves at round about the speed of light, and that the magnetic energy, nicknamed magnoflux, can be transmitted through the magnetic core of a transformer. Electricity is a low-frequency magnetic photon, or magnon, flow inside a conductor's ether. The magnetized spare holes, which mimic the ether found in space and can be moved at the speed of light. Historically, it has been considered that electricity was the flow of electrons, but particles can't move at nearly the speed of light. Only magnons can achieve that speed in the space vacuum inside the electron's outer shell. Here we can see a shaded pole electromagnetic induction motor has only one primary stator winding and a secondary loop of wires embedded in the rotor. If we jam the rotor, it becomes an isolation transformer, and all the power is conducted through the magnoflux field, as the electrons on the primary side are insulated from the secondary loop windings. So we now look at a video of what an induction motor looks like. This is a magnoflux experiment to show you that a a normal induction motor, and this one was taken out of an old washing machine, the drain motor in fact, is totally magnetic. The movement of the energy through the motor is totally magnetic and is not really to do with electrons. Let me just show you what's going to happen when we start the motor. So we switch on the motor, and immediately get about 0.9 amps on the primary winding and 11.5 on the secondary, or the teaser winding here that's making it soft. If we now jam the motor, then up goes the secondary to about 12 and about 1.1 on the primary winding. But let me now unplug it again. And if we take it away now, the magnetism's gone out of here. But all that is in here is one winding, the main winding there, which all the electrons and things go round. But the whole of the power is in the magnet itself. There's no connection between the electrons in the primary winding and the secondary. It's only the magnons in this core that are carrying the whole of the energy. So energy is carried by magnons, and at the heart of the magnon is the magnoflux area. So it's to do with the flux. If we then look at the drawing behind, which I think you can see quite clearly there. So the main winding here, the 240 volt winding, is there. So the electrons, you think were just rushing around in the corners there. But the whole of the power has to come through the magnons, which are in the magnetic core. And of course, once we jam that rotor, then that completed the magnetic path, and the only thing in the secondary then is the teaser winding, or the winding that is shading the pole. And of course, there's a big gap, air gap there, which is stopping it from doing anything else. So the main point of this is to point out that electricity, because it moves at the speed of the light, it's the magnons that move at the speed of the light and not the electrons, and therefore electricity is a very low frequency light. That's all I needed to tell you. Thank you very much. So light and electricity in particular, low frequency light that is, we know a lot about it here on Earth. And what we do know is that the experiments have shown that if the phase angle of the volts is not exactly at right angles to the quantum magnoflux area, a cosine reduction will occur, as there will be insufficient volume of space to contain the spinning magnoflux energy. Looking at the drawing, you can see on the left-hand side the full volumetric cubic space available to transmit the magnon energy, which I've drawn as a square, and that can all move forward at the speed of light. But looking at the one in the middle and the one on the far right, you can see, whereas the diagram has a cosine reduction in this space volume to accommodate the low frequency light. So this then gives us quantum light, or virtual light, exactly the same as we have VRs, which is virtual electrical energy. It's not power. It's just virtual. So what is light? Let's look at a Polaroid camera or a Polaroid experiment showing what it is. This is a magnoflux experiment to show you that photons of light are three-dimensional and occupy just a tiny area of very, very flat space that can be reduced almost to a straight line. So we're going to use some Polaroid film to show this effect. So here we have three pieces of Polaroid, and they are, one of them is at 45 degrees, this one is vertical, and this one is horizontal. So if we shine a polarized laser beam through, we can see the light goes through, and half of it is reflected off the front beam. If we then put a horizontal one in front of it, then nothing goes through, so we don't get any light going through at all. All the light is reflected off the two sheets. Put a 45 in between them, like that, and shine it through, and then the light goes through, and you can see it coming through the back somehow or other, if I can get it right. Now what's going on is this. This is just a wool winder, but it gives you the idea. In the back we have a slot, which you can, in the two slot experiment, you can imagine that is the slot. And this is the light generator, which goes round. But of course it not only goes round, but it goes around that way. So when it goes into the vertical position, the light can go through. When it's in that position, it can't go through. And of course that's light doing this. Now if we now look at to see what happened with Feynman, Feynman managed to do the experiment to produce the quantum light by using an electron and positron and attracting them forward. Use a lot of energy, but that doesn't matter. Now we can do the same thing with ordinary electric light by producing, with the current in one direction, will automatically set up a flux at right angles. So then you've got an area of magnoflux just spinning. Now if you then attract that forward with a voltage, then you'll get power and energy. So what is a photon is in fact controlled by the induced magnon. So what's a magnon? So here we have it. So a magnon is just a magnet that's cut in the middle, and on each side you've got spinning flux. So you've got spinning flux on the south pole going anti-clock, spinning flux on the north pole going clock. When the light moves forward, tumbles forward, then you go clock through there, round, but by that time the anti is over here. Anti-clock, anti-clock, back to the beginning. So it has two cycles to get back to the beginning, but it's cancelled out all the magnetic side of it. And that is where you see magnoflux coming in. So at the heart of every photon is a magnon, and the heart of every magnon is an area of magnoflux spinning energy. Anyway, thank you very much for watching. So you saw that little experiment where we could see it going through. So when a light wave or photon or magnon vibration enters into a volume of magnetized space, the quantum magnoflux spinning field area tries to realign exactly at right angles to the incoming pulses and transmits the magnetic fluctuation forward by spinning a magnetic dipole, which is cut in two, at a balanced set of monopoles rotating around a central swivel area. The two-slot experiment that we've just looked at shows that there are two maximums, and if you can get the slots for the light to go through at the maximum position, then the transmission will go through. So magnons are like a double pyramid of magnoflux. This diagram that you can see on the right indicates that a directional photon can be absorbed into an electron shell by virtually turning inside out into a double pyramid shaped volume of magnetic energy. God said, "Let there be light," and magnetize the universe, and lo and behold, we can see starlight from other galaxies as well as our own Milky Way. If photons or magnons interact with matter or antimatter, then the magnetic quantum energy can be absorbed in the molecule's magnetic enclosure as spinning magnetic heat, or PV is equal to RT gas equivalence. So magnoflux is the balanced spinning magnetic quantum inertial power contained inside a set volume of space x, y, z, which is occupied by a magnon, which is at the heart of every photon throughout all the spectrum frequencies. So photon energy is equal to the total sum of all the different wavelengths of times cos phi per second, which is the same as saying that the electric power is equal to V times I current times I flux root 2 by rooting it, and then cos psi. Difficult concept, but that is what electricity and light are. So light waves or electric pulses are the same thing. So, in conclusion, domestic electricity is effectively low frequency light and needs to be moved through space, through a magnetized space. If the attracting voltage is not exactly orthogonal to the magnoflux area, there will be a cosine reduction in the real power. Because light is universally transmissible, it means the universe to be magnetized and polarized to support it. This results in the magnetic spin effect appearing as dark matter and the polarization as electrostatic dark energy. Thus, some starlight comes to us directly as a laser coherent light beam package of spinning magnoflux inertia energy of various frequencies, as shown in the distribution curve of infrared, of which infrared is the maximum. During a question and answer session, we came across a common problem was, how do you explain what DC is, how that works? So we drew up this particular drawing to try and show what it looks like. This is a standard BH curve, and you can see on it I've got the current marked going on the horizontal scale, going to the right and to the left for negative, right positive. And then the BH curve is in the middle with the voltage going in the vertical direction. So we know voltage is always in the Z direction. So Z direction is up and down. Now what you will notice is that where you get very high currents, I don't know if you can see where I'm pointing here, But if you were running at 800 amps on this 132 or 100 kV line, and you put a load of, say, 600 amps on it, then it would come back to here. So it could then vibrate backwards and forwards on this line, but it's going away from you. So the area, you've got to think of like thin sheets or areas of magnoflux going away from you, or going into the paper and coming out of the paper and then rotating. So in conclusion, domestic electricity is effectively low frequency light. Right, thank you very much for looking at this presentation. And thank you very much to my co-producer, David, for all his help.